Assalamualaikum and hi. So for this week lecture, we're going to learn chapter 9, which is functions and graphs. So let's see, these are the outline for this chapter. So we will have 4 subtopics altogether. The first one will be relations and functions, and second one will be composite function. The third one will be inverse function, and the last one will be exponential and logarithm function. So for this week lecture, I will only cover these two subtopics, which is relation and function, and also composite function. Okay, let's see what is relation and function. So for the first one, relation, a relation between two sets is the correspondence between elements of the first set called domain and elements of the other set called range. So you will have two sets. The first one will be the domain and the second one will be range. Okay, so a relation can be represented by an arrow diagram or an order pairs. So let's see what are these two diagrams or these order pairs. Okay, so the first example, we consider the following example with the relation is the child of for two families. So this is what we call as arrow diagram. So you have domain set over here, and you have range over here. So we see over here Alia is the child of Hamza. So Alia is the domain and Hamza is the range. So you need to have these two set. One is the domain and two is the range. To have, then you can have a relation. Okay, and then the second relation is Ali is the child of Ahmad, and the third relation is Asma is the child of Hamza. So this is actually the relations that you have from this domain. Okay, so actually domain what we call as input. Whatever is the input, we call it or we know it as a domain. And the output will be the range. Hasil dia adalah range. And then we can also represent the relation using order pairs. Okay, so order pairs, we write it down using set notation. For example, we have curly bracket over here. Curly bracket meaning you have set. Okay, Alia is a child of Hamza. Alia, Hamza. And then you have the second relation, which is Ali is the child of Ahmad. And the third one is Asma is child of Ahmad. Okay, so you have three set of relation. Okay, so these are the arrow diagram, and this is the order pair. Okay, let's see the second example. Let A consists of the set which consists of 2, 3, and 5, and B consists 6, 9, and 10. So we consider the relation is a factor of. Okay, we present this relation using both arrow diagram and also order pair. So kita ulang sekali lagi benda yang sama using arrow diagram and also order pairs. So you have the first set, which is set A, which consists 2, 3, and 5, and set B consists 6, 9, and 10. So the input over here, the input we call it as domain, and the output ataupun hasilnya we call it as range. So 2 is a factor of 6, and 2 is also a factor of 10. 3 is a factor of 6, 3 is also a factor of 9, and 5 is only a factor of 10. So these are the types of relation that you have from this arrow diagram. So from this arrow diagram, you can also write your relation using order pairs. So the first one will be set of 2 and 6, and then you have 2, 10, 3, 6, 3, 9, and 5, 10. Whatever you have in here, you will have to write it down in here. Let's say if in here you have 5 relations, so do in this order pairs, you will have 5 relation, 1, 2, 3, 4, and 5. So there are 4 types of relation. Ada 4 jenis hubungan. The first one will be one to one, satu kepada 1. So what does it mean by 1 to 1 is that each element in set X is connected to an element in set Y. Maksud dia dekat sini, satu elemen dekat set X on this side akan dihubungkan atau dipasangkan dengan satu elemen di sebelah sini. So that's why they call 1 to 1. 1 kepada 1. For example, this one. X is the square of Y. Okay, 1 is the square of 1. 4 is the square of 2. And 9 is the square of 3. So you have 1 to 1 relation. 1 kepada 1. The second one will be many to many. So when you have many to many, banyak kepada 1. For example, X is the square root of Y. So you have over here negative 2 is a square root of 4. And also 2 is also a square root of 4 over here, right? So you have many to 1. And also negative 1 is a square root of 1, as well as 1 is also the square root of 1. So you have 2 to 1. This is what we call as many to 1. Banyak kepada 1. And the third relation will be 1 to many. So 1 kepada banyak. For example, over here you have A. It will be connected to C as well as to D and E. So this is 1 to many. And the fourth relation is many to many. Banyak kepada banyak. For example, you have A pair to 1, B also pair to 1, but at the same time, B pair to 2, and C also pair to 2, and then C pair to 3, and D also pair to 3. So this is many to many, banyak kepada banyak. Okay, so altogether you have 4 types of relations. So that's all about relation, which is hubungan. We call it as hubungan. Now we move on to function or fungsi. So you need to you need to differentiate what is relation and what is function. So a function is a special case of a relation which takes every element of one set domain and assign to it one and only one element of a second set, which is the range. The first element is the domain, and the second the first set is the domain and the second set will be the range. So, apa yang dimaksudkan dekat sini adalah fungsi tu adalah special case untuk relation, yang mana dia cuma ambil satu elemen saja. Every element dekat domain dipasangkan dengan one and only one element of the range. Maksudnya dia punya output or dia punya range cuma ada satu, one and only one. So out of 4 cases, out of 4 types of relation we have learned just now, only these 2 are considered as function. The one-to-one relation and also many-to-one relation, because only these 2 yang fulfill, that satisfy or that fulfill the condition of this, that is assigned to one and only one element of the range. So dia cuma pasangkan kepada satu saja elemen dekat range punya set. That's why many to many cannot, one to many also cannot, but only these 2 are accepted, one to one and many to one. So only these 2 relation are function. So a function f from a set x to a set y is surjective or onto, or a surjection if for every element in the codomain of y of there is at least one element x in the domain x of f such that fx equal to y. So I think this is a little bit wordy, but don't worry, you will see what does it mean by all this sentence. If you see this example, okay, which diagram below illustrates a function? Give your reason for your answer. So which diagram? This one. Is it this one? Is this one a function? We see A pair to this one pair to this, and C pair to this. This is actually one-to-one and onto function. So this we call it as a function. But this one, when it is one-to-one, it is onto. Kita panggil dia onto kalau dia one-to-one. When it is not, this one is one-to-one. Okay, one-to-one as well. But this is not onto. Why is it not onto? Because ada satu pasangan. There is one element over here which have no pair. Okay, dia tidak ada pasangan. So that one we call it as not onto. Okay, onto di sini bermaksud all the elements must have the pair. Mesti ada pasangan. That is what we mean by onto. This one over here, we have all the elements are paired with this element of A, of set A. But in here, there is one element over here in set B which have no pair, tidak ada pasangan. That's why we call it is one-to-one function, but it is not onto. So when it is not onto, we call it as not a function, bukan function. Okay. And how about this one? This is one to many, satu kepada banyak. So obviously this is not a function. And for the this case, okay, we have there is an element in the domain not mapped to the element in the range. Okay, let's see for this one, C. C dia tidak dimapkan ke set yang range ni, dia tidak ada pasangan, as well as these three numbers over here, three elements, tidak ada pasangan. So this is obviously not a function. So I hope you're clear about what is onto, what is a function, which one is not a function. And then we have vertical line test. So what is vertical line test? Okay, to test if a graph display is a function, we use this vertical line. So kita mau uji whether graph tu adalah fungsi atau tidak. And then these vertical lines are drawn parallel to the y-axis. Okay, this line dilukis secara menegak, sama macam y-axis. And the graph is a function if each vertical line drawn through the domain cuts the graph at only one point. Okay, so suatu graph itu kita consider sebagai suatu fungsi bila mana vertical line yang kita draw tadi cuma potong graph tu sekali saja, cuma potong pada satu point sahaja. So kalau dia potong pada satu point, that we consider it as a function. For example, we have this kind of graph and this kind of graph. Let's see the first one. So when you draw a vertical line line test, this one is the vertical line. So this vertical line over here only cuts through one point in here. So this one, we consider it as a function. But how about this? When you have this type of curve, this straight line of this vertical line cuts through 2 points over here and over here. So this is not a function. And then for this type of graph, similar, it only cuts 1 point at 1 point. So this is a function. So how are we going to write the function? This is we call it as function notation. It can be expressed by f(x) equal to y, or we write it down in this way. Either you can write it down in this way or in this way. Both are correct. Okay, example. A function is defined by f(x) equal to x squared plus 5, where x is element of real numbers. So find f3, f-5 and fx-1. So that is how we're going to find this. This is just the example how you're going to write the function. We're not going to solve it. We're going to solve it later on the next example. Okay. I just want to show you how we write down the function. So it can be written down in this form, or in this form. What does mean by f3 is that you're going to substitute the x value over here with the value of 3. And over here you have f -5, meaning that the x value you're going to substitute with -5. And this one you're going to substitute the x value with x minus 1. So we will see this type of example later on. So let's move on to domain and range. The first one, domain of fx, domain of function is the set of values for x, is the set of values of x for which fx is defined, and range of fx is a set of values of y for which elements in the domain map. Okay, macam yang saya katakan tadi, domain adalah any values of x, x values ataupun you punya input, and the range will be your values of y, or can also be called as your output. So we can evaluate the domain and range by using graph and algebraic approach. So ada dua cara untuk tentukan you punya domain and range. So before that, let me see the basic shape of a function. We have this basic shape of a function. The first one is quadratic function. So this is what you have learned before. This is actually kind of parabola curve, right? So you have fx equal to x squared, this type of graph. If there is negative x squared, you will have like this. And then you have a cubic function, kuasa 3. You have like this. And bila ada negative, you will have like the contrary on the other side. And for the third function, the graph exists only for x greater than or equal to 0. So untuk fungsi punca kuasa, macam ni ada third, dekat dalam ni dia mesti lebih besar atau sama dengan 0, because we cannot have set of negative numbers. Okay, it must be at least 0 or greater. So this is how the set function looks like. Either this is the positive one and this will be the negative. Negative at the outside of the set is okay, but not inside the set. Okay. And this is reciprocal function. Reciprocal means you have 1 over. So that is reciprocal. So it's kind of like a butterfly graph, butterfly curve. Okay, this is a positive, y equal to 1 over x, and this is y equal to negative 1 over x on the other side. Dia berbalas saja kontra. And then we have absolute value function, which is this one. Absolute value mean you have modulus. Kita ada modulus. What does it mean by modulus? You will have anything inside the modulus sign or the absolute value, will get it positive. At the end, the answer must be positive. For example, you have absolute value of x over here. So all the value are positive. Tidak ada yang di bawah graph itu. Okay, and for this one, you will have absolute value of x squared minus 3x plus 2. The graph should be look like this, right? It should be look like this. Asalnya dia sepatutnya nampak macam ni sebab quadratic. But since this is absolute value, semua yang dekat bawah, all the graph that are on the negative side, di bawah paksi x, dia akan pantulkan naik ke atas. So you will have like this. Asalnya dia macam ni, yang garis putus-putus ni. But then, originally it was like this. But then, because of the modulus sign over here, or the absolute value, you will have to reflect this curve upwards. So semuanya, everything will be above the x-axis. Okay, so we refer back to the graphical approach. The way you're going to find domain and range, there are two ways I mentioned previously. The first one is graphical approach, and the second one will be algebraic approach. So this is the graphical approach. Find the domain and range for the following function. This is a constant function. Constant. You have fx equal to 3. Okay, constant. So you have a static or straight with a horizontal line over here. Fx equal to 3. Fx over here you can write it down as y equal to 3. Then you have this kind of graph. So the domain will be your x-axis or x value. Okay, x value. The range will be the y values or the y-axis. Okay, so the domain will be from negative infinity until positive infinity. You can continue this straight line up until the end of positive infinity as well as to the negative infinity. You boleh panjangkan dia. So the domain will be negative infinity until infinity, and the range will be, range akan tetap. Range tu maksud y values ataupun y axis. Y value dia ini sahaja, which is y equal to 3, which is only 3. Okay. Okay, this is the second example where you have fx equal to negative 5. So the only difference is the value over here. Okay, previously you have fx equal to 3. This one you have fx equal to negative 5. So you can write it down as fx is actually y equal to negative 5. So you will have like this, a straight line below the x-axis because it is negative 5. So the domain will be sepanjang yang inilah. So negative infinity until infinity, and the range will be only this straight line, the y values or the y-axis. Okay. And for linear function, you have fx equal to 2x plus 1. So this is actually how I obtain my graph. I'm using this range or this domain and range. Let's start from negative 1, 0, 1. It's up to you. You want to start it from negative 5, negative 10, 0 or whatsoever. As long as you can write, you can have a point on your graph. Okay, so these are the 3 points that I map into my graph. So I have over here negative 1, 0, 1, and as well 1 and 3. So this I just fit in this x value into this. Bila you fit in this x value into this, you will get the y value of this. Okay, ganti masukkan saja this x value ke dalam this fungsi dan you akan dapat value untuk y. So the domain will be from negative infinity until infinity. Sebab kalau you panjangkan, ikut panjang dia akan jadi positive infinity, and bila you panjang ke bawah dia akan jadi negative infinity. So as it is the same with the range, negative infinity until positive infinity. And then you will have the second example, which is negative x plus 2. So since this one you have negative x, so the graph will be decreasing like this. So it's similar. Pick any points, pick any 3 values of x. It's up to you. You can use only 2, or you can use 3, or you can use 5, up to 5 values, so that you can obtain your graph clearly. So for this one, I only choose 3 values of x, then I substitute into this here, this function over here, to obtain my y. Okay, remember x is your domain, x over here, and then this is your range. Okay, but this range is not fixed yet, since we want to know the true domain and range, which include all the possible values of x. So you will have like the domain will start from negative 1 until 3. Dia start dari sini, negative 1 until 3 saja domain dia. And the range will only cover from, sama juga, from negative 1 until 3. So this is the difference with the previous one. And this is for the quadratic function. You have fx equal to x squared minus x minus 2. When you perform a completing the square method, I'm sure you can do this, completing the square. So you will get this one. Okay, so this is actually the graph of parabola ataupun graph senyum macam ni lah. So you will have your y-intercept equal to -2 and your x-intercept equal to -1 and 2. So this one, pintasan paksi x dia adalah yang ini, pintasan paksi y dia adalah -2. So the minimum point over here is this one, minimum point. Okay, the minimum point yang ini. Bila you ganti masuk this value of y ke dalam this function. And then you have domain. Sama juga domain ni bila you panjangkan kiri ke kanan, you will have negative infinity and positive infinity. And then for the range adalah untuk paksi y. So paling minimum range tu adalah start from here. -9/4 up until here positive infinity. Okay, that one is the range. Ingat, range is for your y-axis. Domain is for your x-axis or x value. So it's quite similar with this one. You have, it's just that this one is negative over here, so your graph looks like this. So you need to update and using the completing the square so that you can find your maximum and minimum point. Since this is the negative curve or negative graph, so you will have maximum point over here, which is -2 and 9. And the intercept will be over here and over here. So the domain, sama juga. Domain ni kalau kita panjangkan, it will have negative infinity until positive infinity. And the range adalah paksi y. This one is untuk x. Okay. So untuk y-axis, it will start from negative infinity sebab dekat bawah kan it's going downwards. So negative infinity until paling highest dia boleh pergi cuma 9. It cannot reach up until here. So it's cukup sampai 9, up until 9 only. And this is the example for cubic function. So you will have like this curve, so the domain and the range is easier, negative infinity and positive infinity. This is for cubic, kuasa 3. And when you have a kind of graph like this is actually a cubic as well. It's just that they factorize it. So you have like this. Okay, so it's quite similar. The domain and range will be the same, negative infinity until positive infinity. And for the third function over here, let's see, you have third function x plus 5. So in here the value must be greater than or equal to 0. Mesti lebih besar atau sama dengan 0. You cannot have negative numbers over here. That's why you have x must be at least greater than or equal to -5. So that kalau dia -5 plus 5, then it can be 0. Square root of 0, you get 0. So this is the graph for third function, for this third function. So your domain adalah paksi x. So it will start daripada sini, -5 up until positive infinity. Itu adalah range domain kamu, x values yang kamu boleh ganti masuk dalam this function. And the range will be from 0, sebab dekat sini graph tu paksi y, from 0 up until positive infinity. And how about this? You have 9 minus x squared and then square root. So this one have to be greater than or equal to 0. So you recall back your chapter 2 or chapter 3, which involve inequalities. So you will get when x equal to 0, fx must be equal to 3. So we'll get this one. So you have this kind of graph, -3 and -3. So your domain tu adalah paksi x. Dia terangkum di antara sini ke sini, -3 until 3. And your range will only cover this area. This is your range. Okay, and this is your domain. And This one is also set function, it's just that 1 over. It's a combination of reciprocal and set function. You have 1 over set function, so everything that involves set function, it must be greater than or equal to 0. But since this one, you have 1 over, so it cannot be 1 over 0. That's why it must be greater than 0. Dia tidak boleh 1 over 0, tidak akan dapat jawapan. Okay? That's why dekat sini kena sekurang-kurangnya greater than 0. So you have x greater than 2. So the graph will look like this. This x minus 2, you will get x equal to 2. This is actually the asymptote. This one. The asymptote. Okay, dia tidak boleh. When you draw the graph, the graph or the curve cannot touch this asymptote. So your domain will be start from 2 until infinity, but not touch 2. It's not using the cross bracket. It's using the open bracket. And the range will start from 0 until infinity, but not touching the 0. And this is absolute value function. Fx equal to modulus x. So you'll have like this, and your domain will be this, and your range will be starting from 0 up until infinity. And it's the same with this x plus 4. It's just that you have x equal to negative 4 over here. So the range will be the same, and also the range, domain and range will be the same like the previous one. And for this one, you have only the x is the absolute value or have the modulus function. The negative 2 is not a modulus or not absolute value function. So you'll have like this kind of graph. Okay. So what you have, the domain is always going to be negative infinity until positive infinity. The range, you have to look back, where is the bucu or the vertices of the curve. So you have starting from negative 2 up until infinity. Sebab range is your y-axis or y value. And this is about for piecewise function. Fx equal to negative x squared for x less than 0, and x plus 5 for x greater than or equal to 0. So bila ada piecewise functions, so you have two kind of graph. The first one will be this, and the second one will be this. So the domain will be from negative infinity until positive infinity, and the range you will have 2. Sebab dia terpisah, because it is separated graph, it is not connected. Okay, so you have these two range. So the first one will be from negative infinity. Range is your y-axis. Okay, your y-axis. So the first one is negative infinity up until 0. This one. This is for this. And this one is for this. This one it start from 5 up until infinity. Sebab kalau kita panjangkan, dia akan jadi up to infinity. And it's quite similar with this one. So you have this kind of graph, curve, and this one of curve. So the domain, it is connected over here. It is connected. This one is, the previous one is separated. Dia tidak bersambung. But this one, it is connected. Okay, ada intersection point dekat sini. So the range, the domain will be negative infinity until positive infinity. And the range will start from 0 over here. Paksi y dia adalah 0 up until infinity. That one is using graph. So next we have algebraic approach. Okay, this one without the graph. Find the domain and range for the following function using algebraic approach. So for A, let's say you have function 3x plus 1. where x is element of R, real numbers. So the domain, if you see like this, the linear function, you know that the domain will be negative infinity until positive infinity, as well as the range. This one is the easiest, paling senang kalau you ada linear function. So the domain and range, you can simply letak negative infinity until positive infinity, because you will, if you draw the graph sekalipun, the graph will be like this. Dia akan naik ke atas. It will be a straight line, naik ke atas. So daripada can be like this, daripada negative infinity atau positive infinity. Okay, and for this one, for fx x square minus 3x, this is actually apa tu, parabola or graph macam ni kan. But without using this graph, you can simply use the completing the square. So from there you can find the range and the domain. And this is for the third function. So remember, for third function, must be greater than or equal to 0. So you have x less than or equal to 2. So you will, the domain x tu mesti lebih kurang, lebih kecil atau sama dengan 2. So paling maksimum x tu adalah 2. So it start from negative infinity up until 2. And by inspection, you akan dapat your range start from 0 until infinity. Range maksudnya you punya paksi y. When you have x value equal to negative infinity, your gx or your y, this one, your gx or your y will be positive infinity. When you have your x equal to 2, your gx equal to 0. Ni maksudnya kalau you ganti masuk dalam this one. Bila you ganti masuk ni dalam the function over here, dalam this function, dalam gx, the x value you substitute dalam sini. Bila you ganti negative infinity dalam x, you akan dapat your y pun positive infinity or your gx. Okay. So sama juga, bila you ganti this value dalam 2 dalam sini, you will get your gx equal to 0. So you can now obtain your range, which is start from 0 up until positive infinity. And last example, also a combination of reciprocal and a set 1 over set function. So over here you will have, okay, wait for a while. Over here you have x minus 2. Since this one is 1 over, or the denominator, it cannot be equal to 0. So it has to be greater than 0. X minus 2 mesti lebih besar daripada 0. So you get x greater than 2. So your domain, you know that your domain will start from 2 until infinity with open bracket. Does not include 2, tidak termasuk 2. And here is when you substitute the x value with 2 ke dalam sini. Bila you substitute x value equal to 2 dalam sini, so 1 over square root 2 minus 2, this one become 0, kan? So you will obtain positive infinity. And then when you substitute x value with infinity, this thing will become fx. Hasil dia akan dapat 0. So, oops. I'm going to erase it. Okay. Okay, so when you substitute x equal to infinity, your fx you're going to get equal to 0. So now you can obtain your range, which is your y value. Range is your y values or your output, or actually we call it as fx. Your fx bila dah ganti masuk value untuk x tadi. So it will start, your range start from 0 up until infinity. Okay, I think that's all for this subtopic, relation and function. We have covered What is relation? There are 4 types of relation: one-to-one, many-to-one, many-to-many, and one-to-many. There are 4 types of relation. And then we just learn what is a function. So a function, it must be one-to-one or many-to-one function. And what is onto? Onto mean dia mesti one-to-one. It has to be one-to-one, and all the elements in the set must be paired to the other side. Mesti ada pasangan dia. If not, if there is no pair for the function for the element, then we call it as not onto. Then in function, we have learned how to find your domain and range using graph method or graph approach, and as well as the algebraic approach. Okay, we'll see the next subtopic later. Thank you.